Hello, my name is Alistair Plotnick,
My name is Yair Hodgeberg.
and this is our project.
So, our purpose in this project was to find the effectiveness of electrical vehicles on emissions in society in general. And we decided to take a step further and see how the densities of electric vehicles in a population would have any effect on the emissions in that said area. So, what we expect to see is that in areas with more electric vehicles, there'll be less overall emissions, but specifically carbon emissions, as that is what measures those come from gas.
And so for our data collection process, we started by just looking up for data sets, and we checked government websites as the ones listed on the project documents, and we found that the state of Washington had the most data on their electric vehicle registration overall carbon emissions. Washington State is the fourth highest state with the most amount of electric vehicles, so we felt that was a good state to pick for representation. We gathered JSON and CSV from data.gov. Our JSON contained monthly data about how many electric vehicles and non-electric vehicles had been registered to the state every month, and our CSV contained the description of every registered vehicle in the last decade, which included their make, model, year, as well as where they were located, so which electric company would be their supplier. And then our HTML, which was from Wikipedia, contains data about the primary usage of vehicles, as well as a list of all electric vehicles made since 2000. So that was just going to be used kind of as an XLOOKUP to see what the primary use of the vehicles were and see how much they would be using for passenger versus trucks.
So, to dissect, I guess, the Wikipedia site, we used beautiful soup to parse through the data set. So there's a few tables on this website that we wanted to get data from specifically. So we used find all to kind of access all the tables possible and then use their indexes to select the right tables. And extracting the tables, there were some columns that we didn't, need the data for. So we used find all again to kind of get rid of those columns as well. And then after we got all these columns, we kind of just used for loops to insert these columns into our pandas data frame. And then to kind of address an inconsistency we had where the names of the passenger vehicles, that weren't passenger or truck, wouldn't line up. So we used np.aware to kind of filter out what vehicles are, either as a passenger vehicle or a truck vehicle. And then our final table is just the list of all the electric vehicles ever produced and then their primary purpose. So starting off for the JSON file cleaning, we got the URL and then just used requests to turn that into a Python dictionary, using also from the requests with JSON loads. After doing that, kind of just went through the data, going to, through the dictionary, seeing what is the right location for our data, and then after kind of finding all the relevant data, kind of just put that all into a data frame and then dropped all the irrelevant columns that we didn't need, and then just kind of did some simple cleaning stuff like renaming the columns for clarity, getting rid of all the null values as well. And then kind of an inconsistency we had to deal with that we got rid of was that there's some characters in a string that were kind of unnecessary and wouldn't line up with all the other CSVs. So just dealt with that using string split methods on the columns, and then more or less just kept working after that, and then exported it to a CSV file so it's easier to access. And yeah.
So then for our CSV, this was the CSV containing all of the registered electric vehicles in the state of Washington. So we used pandas to read the CSV file and dropped the unnecessary columns, as well as the rows that had battery ranges for the electric vehicles as too low because those cars didn't want to consider them. And then we grouped by the geographical region as well as the electric utility supplier and make, model, and year. To get counts of if there are any of the same electric vehicles in the same county, just for ease of making the data smaller and having less rows, so we could get sums, and then renaming some of the columns, and that was that. And then we did have one additional CSV, and this was for the total emissions. So again, using pandas to read in the CSV and then drop the unnecessary columns. We only wanted the years greater than or equal to 2015, as that is when electric vehicles started becoming more prevalent and produced more, dropping rows that did not have all of the emissions data that we needed from them, and then grouping by year, city, and county, and summing all the total emissions from those areas, and then making a new column of total emissions. And according to the Cato Institute, it said about 16.4% of all emissions are due to transportation, and so made that column based off total emissions.
So this first insight kind of just deals with the number of electrical vehicles in each county. So we decided to find the county with the maximum amount of electric vehicles, which is King County at 97,399. We did this to kind of get a general idea of the EV population across the entire state as well as its density. And this result's not very surprising. King County is where Seattle is located, which makes sense because it's urban and it's also the most dense or the most populated county in Washington state. So our next goal was to find which area in the state had the most emissions in the state, as well as which had the most non-electric vehicle usage. And insights 2 and 3, insight 2 is the emissions, and that was King County. And then insight 3 was the largest amount of non-electric vehicles, which was also King County, which is pretty ironic since it also had the highest amount of electric vehicles in the state, which also, all this data also makes sense due to the high population counts in Seattle, leading to a high amount of vehicles overall, as well as the industrial activities. Our fourth insight told us that 52% of electric vehicles in the state of Washington are passenger vehicles, with the other 48% being trucks. And this shows a good insight into what companies such as Amazon or others may have been doing to make a push to have their company go greener and use electrical vehicles for transportation instead of gas vehicles.
So moving on to our fifth insight and first visualization, we wanted to see what the leading manufacturers were in counts by county of leading manufacturers. So for our fifth insight, it was a breakdown of how many, what was the leading manufacturer per county. So as you can see, it was Tesla in the top 2 counties and those counts there, as well as here's a breakdown overall of the leading manufacturers for all of the state of Washington. You can see that Tesla has about 52%, and then Chevrolet and Nissan with about 9 and 8% respectively. And these pretty accurately reflect the total U.S. market for electric vehicles, as Tesla currently has about 48% of the market share, and with Chevrolet having about 10 and Nissan about 8 as well. So for our second visualization, we did a breakdown of car emissions in 2022 by county. So we took the total emissions and multiplied them by 28%, as the Cato Institute estimated that in 2022, 28% of U.S. emissions were due to vehicles, and King County, again, was the highest due to its population, urban area, and industrial activities. So you can see they're the highest, followed by Lewis, and then Pierce, and then all the way down to Jefferson being the lowest. And then for our last visualization, we had a graph of electric vehicles released since 2000. And in contrast to the previous graph, although emissions have been the highest in 2022, you can see that only more electric vehicles have been produced since 2020. As more have been released, there hasn't been a show in decrease in emissions.
So our overall results say that even though our overall goal is to reduce carbon emissions and be cleaner, the number of total emissions or carbon emissions have not seen a reduction in total output across the entire state of Washington, which is the state with the 4th most EVs. Although the vehicles are a contributor to around 28% of total greenhouse gas emissions yearly, as the EV usage rate increases, there still has not been a significant decrease in emissions. Therefore, we cannot really draw some sort of correlation between more use of EVs and less emissions through our data. Some confounding variables we ran into is that we did not have population counts or consider where industrial plants are in the state, which is very important, especially considering King County, where Seattle is, which popped up many times when we were looking through our insights, just due to the fact that it was the most populated county in the state of Washington.